more program videos side here. Hope you guys are doing well. Hope you guys are having a good New Year's in the Gregorian calendar, and hope you guys are doing good in the upcoming Lunar New Year calendar. And hope you guys are doing well. And Valentine's coming up. Spread the love as always. And yeah, in this video today, we're going to be going over specifically how regenerative e-bike brakes work in an e-bike brake system. So let's just talk about some updates. First off, some of the viewers who are watching, I am aware you guys wanted these links with the GeoGebra simulators. I haven't been posting them a lot lately regarding with not the e-bikes, the simulators from GeoGebra and the videos that we use to show you guys how these systems or how these things work in physics terminology. I wasn't able to get that time, unfortunately, due to time restraints. So in compensation for that, you guys can take a look as the links are there on the bottom. It should be in the videos. Not at the bottom of the video, but in the screen, you guys can see that there's a link there. You guys can just copy up that link and it should take you there directly. I'll try my best as much as possible. If you guys have, I'm trying to we're focusing on the big project as of this time. So that doesn't mean I'm going to abandon ship on this part as well. So what I'm going to do essentially is that, as we go along with these videos, you guys can copy and paste the link. You guys can type up the link and you guys can see that there's certain simulators. You guys can get straight directly to the videos and the simulators directly. So just want to let you guys know specifically regarding that. And yeah, without further ado, let's start. So what is regenerative e-bike brakes? So the meaning behind this is a way to turn back braking energy to electricity to charge the battery. It uses this bike motor to slow down and recapture the energy charged from the battery. So essentially we're converting kinetic to electrical energy, and we're using that to charge the battery instead of wasting that as excessive heat. Because we want the main goal for the e-bikes to work is that it needs to generate electricity to power in longer duration time period. So we have the kinetic energy formula. We have E equals half mv squared. The M represents the mass of the bike, in this case the e-bike. The velocity is the speed of the e-bike, and the energy is the kinetic energy of how much it's moving the electric e-bike. A fun fact is that actually electric trains and trolleys, in fact in Ottawa, Canada, they've used these brakes back then to actually power their systems to move forward and pick up passengers as they go. The more momentum means more juice, and really in general, just a summary of this is how the regenerative brakes work. It's braking, energy conversion, battery recharge, and braking force. Really, that's how it's kind of really propelled towards. So here's a good link. This is a very good link that goes really in depth.
I've seen plenty of power decks over my 15 years of reviewing tech, but this Ridge one quickly became a favorite. So this.
What's up, YouTube? Today I'm going to show you guys how to activate regen braking on most e-bikes. A lot of people don't know that the controllers actually have a built-in regen capability. All you have to do is open the controller and turn it on. Well, it's much easier said than done, but I'm going to show you guys exactly how to turn or activate regen braking on your controller. That way, whenever you toggle the brake, it's much easier for you to stop. You stop much quicker and harder, and also you get a little bit of electricity kickback to your battery. I've already done it on this bike. I was actually able to get an additional 2 or 3 miles extra. That's really not why I did it. I did it because of braking. This bike, depending on what battery I have, can go up to 40 miles per hour. I needed to be able to stop aggressively, and the regen braking really helps you come to a complete stop. So for me, this is the number one reason why I did the regen braking.
So this video, shout out to Cola. He goes really in depth regarding with this specific video in terms of the e-bike tutorial, really how he's going to go into the disassembly portion and then really the brake system of how it works. Oh, look at that. There's some circuitry right here. So let's actually take a look at that as well, actually. That's kind of looks really cool. But notice what he said here specifically, that in terms of regenerative braking, the purpose of it is not to just propel the bike forward. It's not really that. So that kind of contradicts what I just said right there. So it's not to just go move the bike faster. It's to really stop the bike, because the bike is gonna keep going forward. It's gonna go like 40 miles per hour, that kind of thing. You want the bike to stop, like stop. If it doesn't have strong friction to stop, then yeah, we're gonna get into some big accidents over there. So the real goal is to stop the bike, not to keep propelling forward. That's just some clarity that he kind of made in this video to kind of tell us as the viewers. So yeah, let's take a look at the circuitry part. I do want to see this really cool. So let's see this part as well. I'm kind of a bit interested right now.
Once you unscrew all the screws around your controller, then you can slowly pull it out. Okay, so now you have your controller. This is what most controllers look like. This is your capacitors right here. These are your capacitors. And this is the brain of your e-bike. Now let me show you what you need to do. Alright, so once you have the controller opened, what you need to do is solder these two together, this X and DS. This will activate region braking. But keep in mind, this only works for direct drive. It will not work for geared motor e-bikes. And it is also important to note that this can only work if you have a single battery. It would not work if you have dual battery. It can mess your controller up if you have dual battery. I usually have two batteries, but they are not usually connected at the same time. My two batteries only connect. I connect one at a time, so two batteries physically on the e-bike, but one battery is only working. And when that's dead or low, then I switch to the other battery. Once again, you do not want to do this if you have two batteries connected in parallel. You can only do this if you have one battery connected at a time. So the easiest thing to do will be to solder these two together, and that will give you region braking. So just like that, I have soldered these two together, and this is now what it looks like on my e-bike. These two right here gives that region braking that we've all been looking for.
So this is a very good important point. We did go over some circuitry as well. So we did dive into some Ohm's law in here specifically. He did talk about a little bit of touching into circuits. Here specifically, he goes in depth within the circuit that this system, there's a DS circuitry over here. We don't just use the DS system here. In this case, we also use the X system here as well. And we cannot notice that he said that we do not put these in parallel. The batteries are not used in parallel. We try to put them one by another, so that way the circuit powers up the battery. Really. We want the battery to power up on the circuit, so that way the board, or the circuitry board, can produce electricity. So it's better to sew these two together, so that way we can conduct more electricity as time goes on. So this circuit's a really good thing that he did here. It's really awesome. He goes really in depth in this. I definitely recommend Cola as well. It's a really good. He's really good at explaining things. So now let's go over normal bike brakes. So typical normal bike brakes. Let's go over this right now. Normal bike brakes. Brakes review, really, it's simple. We've gone over some depth in terms of just normal bike brakes. Specifically, it's simple, cheap, reliable. The difference, though, with this compared to e-bike brakes is that it wears out from 500 to 2,000 miles. That'd be crazy if it was 5,000 miles or more. Actually, hey, it could work if it wears out even more than that. So the normal bike brakes, they can wear out very, very long. It uses friction to convert energy as heat, and it's essentially wasted, though. We're not kind of using it to power the e-bike system. For a normal bike, we're just kind of using it as heat. It's kind of wasted. So really, that's the case here. And yeah, we can see that these are all the types of brakes that we have here: drum, disc, roller, V, caliper, cantilever, and we have, how this really works: hydraulics, rotor, adapter, caliper, and bosses in terms of this. So here's a comprehensive resource, I would say, that goes in depth with normal bike brakes.
Braking, but regenerative braking in order to and then work your legs up and make you burp out a cheeseburger sandwich or something. Chemical reactions, chemical energy production tends to be a one-way path.
So this link really, I'm not gonna go into this. Is a real good explanation in like 40 minutes, over 45 minutes actually, in terms of his presentation of really what is a regenerative bike brakes and how they really work in this case. He goes really in depth, really when it doesn't work, flywheels, freewheels, and he goes in depth really in terms of motor drag and how much you can get within certain areas of the world. So really, it goes in depth within like the systems of really how circuitry works and other things. This presentation is really good. I recommend that as well. So now let's go over the physics applications regarding with how this works. So the physics application with how this works, how does it work? So for step one, when riding fast, your kinetic energy produces the heat, but that heat turns into electrical energy. And once the motor spins backward when braking, the motor is going to essentially spin backwards, and that braking system is going to generate electricity as time moves on. And when braking, there's a negative acceleration because it's moving backwards. It's going to act in opposite of motion. So there's going to be frictionless braking as well. And that is essentially the rotational motion that occurs when it goes backwards. It's going to produce that electrical energy for the bike to essentially power up. But please note that not all kinetic energy is recovered at some efficiency. Typically 60 to 70% max on the e-bikes. And really we have to use the energy efficiency formula, which is energy output over the energy input, which is the kinetic energy that we're using. And we multiply it by 100 to get the percent efficiency. So you can see here, there are two different types here. This is a car, really the acceleration, how the braking works. See here that the acceleration is actually opposite to its motion. So you're seeing here that it's going opposite to its motion within the car system. And we're seeing here that the gasoline engine, the electrical motors, and the batteries is all powering up the bike itself. And this is all due to the kinetic energy brakes, the kinetic brake energy from these regenerative brakes. And here we can see here, this is just a bike that's kind of using kinetic energy. Friction is going up this hill, and he's basically going downwards as well. Air resistance plays a role in this case, but when we talk about this kind of thing, really how it works, air resistance doesn't really play here. We're just talking about specifically bike brakes and how they itself produce kinetic and electrical energy. So just keep that in mind. Next, we're going to talk about magnetic resistance. Magnetic resistance and how it works specifically is the magnet's position on a flywheel. It generates this magnetic field, and this creates something that's called a flywheel drag. Now, we've gone over drag before. It's really, it's a kind of like a frictionless. It's a friction system. It stops. It's a drag. It's drag. It kind of slows something down. And the resistance relationship in terms of magnetic resistance is that the more proximity, the more close the magnets are together to these flywheels, which essentially looks something like this right here. It's like the back of like a big bike. So these bike exercising machines, they have this kind of like flywheel over here in the back of the bike, and this essentially creates the drag. So the more the magnets are together, the more resistance. The less the magnets are positioned together, that means that there is less resistance. And there are electronic controls that occur. It adjusts. The purpose of these electronic controls are usually in the flywheel system. It's usually on the metal parts of here. Really the main goal is that it adjusts the magnetic field to simulate hills to provide consistent power output, and it's controlled by a computer app. There's a simulation software that we use, and there's some programming that's used to help these controls control these bikes properly and make sure they stop efficiently. So the goals of these controls is they're powered and programmed to stop these bikes properly. So you can see here, this is like a typical magnetic magnet that occurs in interaction with iron, copper, aluminum, and also air gaps. This is really the system of just a magnet. Here we have magnets and a flywheel in its together system here combined. There are currents, rotation, rotary motion, and currents that are also there. And we see here, just in general, the resistance and how it works. So really, this is just like where the things are really located. This video goes in depth regarding.
Whoa, what's that? I just got the budget app for phase 44.
AI
just built an app.
I hope not, but AI. We better understand AI ethics though. Let's just be careful on that one. Anyways, so can flywheel technology make cycling easier? This video, he goes in depth regarding, can it make life easy for cycling? A lot of people have done this. A lot of people have, debated about this. But let's see what Tom Stanton has to say about this. Let's see.
A kinetic energy recovery system stores energy during braking to later assist with acceleration, instead of wasting the energy as heat in the brakes. This is very similar to regenerative braking in electric and hybrid cars, but in some cases the energy can be stored in a flywheel. And if you're a subscriber of this channel, you'll know that I love flywheels. So let's build a bike with a flywheel kinetic energy recovery system. The plan is to use a bike that I previously made to be air powered from another video, as the frame is a simple tubular design and has lots of space for a flywheel. Plus I already have a CAD model of it, so that will save some design time. From this I can work out how large of a flywheel I'll need, which seems to be about a 30cm diameter. So where on earth do I get such a flywheel? I have a CNC router to cut parts for a lot of my projects, but I've never cut anything heavier than aluminium. Ideally the flywheel needs to be made from steel, as steel is 3 times denser than aluminium. Whilst browsing the internet for steel sheets, I found a bunch of sellers on eBay selling laser cut steel discs to the perfect dimensions I need, which saves me a ton of work. To turn this steel disc into a flywheel, I first measured and drilled some holes on a friend's drill press, but because I measured the hole positions by hand, they probably won't be perfectly aligned. So I positioned the flywheel at a distance from my camera and took a photo. I can then import this image into my CAD software and make a model of the flywheel, which shows the centre of the drilled holes to only be out by 0.086 of a millimetre, which was a pleasant surprise. Also, I can use this template to design some side plates that will correct for this small misalignment and allow the bearings to be mounted either side of the flywheel. The purpose of the disc brake will become clear later. The next step was to make the brackets that will hold the flywheel inside the bike frame. These were cut from 6mm thick aluminium sheet, which should provide plenty of strength to keep the flywheel from breaking loose at high RPM. It was then time to check if my measurements and design were correct by attaching everything to the bike. And there we have it, a flywheel on a bike. Now we need to figure out how to connect it to the rear wheel to capture the braking energy and assist with.
So really, he's going to go over the experiment really of how flywheels would essentially work and power the cycle to make life easier. So he goes over this real good using CAD, using software. He goes really in depth with the flywheel and how really goes in depth. Diameter plays a big role, size plays a big role. That's a good thing to know here. Take a look at Tom Stan. He's really good. This is the link for it. I'll do my best to see if I can try. I'll try my best to put these links as well. The last thing we're going to go over is the benefits and drawbacks, really. We haven't talked about this. The benefits and drawbacks of having these brakes in these systems of the e-bike. So the benefits, well, increase the travel distance, reduces overall drainage of battery, extends the brake pad life, so I don't have to buy new brake pads, right? You know, because you know how legit expensive they are nowadays. Lower cost due to less wear on the e-bike brakes. It's smoother stops, better downhill controls, and you can stop much more efficiently. You can stop properly when you go in during long duration period of distance. And long duration period of time, when you're going long distances, you can stop automatically when needed. Drawbacks though, it is no fully charged batteries. There's a high danger of voltage. You're going off-road. That's a big danger. Huge stress on the frame of the bike. You know, there's a lot of endurance that the bike goes when it's going through these things. Limited stopping power. It doesn't go all the way. It depends on the surface of, you know, where it is, friction. These play a big role. Air resistance. It limits stopping power. The motors, please note that it requires direct drive hub or geared hub motors. Wink, wink, wink. Take a look at the previous video that we've gone over regarding drive hubs and gear hub motors. Without these hubs, we cannot use the motor. We can't use the motor essentially. The motor needs these parts for it to work as we go along our journey. The motor adds significant weight to the bike. We're not talking about like milligrams. We're not talking about grams. We're talking like a bunch of kilograms or probably something higher than that. But really in general, it's really heavy. Motors, they are very crucial for the bike to kind of sustain itself. But I think in general, motors might not be that heavy. Let's just take a look at that really quick. How heavy are e-bike motors? Let's just see. I might be wrong, actually, maybe. I might have to double check on that one, guys. Oh, yeah, well, never mind. It's 2 to 5.5 kg. Yeah, that's pretty heavy. Pretty heavy if you ask me. 16 pounds. That's like a baby. That's heavy. That's heavy. But yeah, that's something else to kind of note as well when we talk about that. So yeah, there are benefits, there are drawbacks. There are more benefits than drawbacks, but please keep in mind, you know, as long as you have a good bike, you can keep moving forward as time goes on. So that's all really we have for this video today. If you guys have any questions, feedbacks, or upcoming lessons, please feel free to email us. You guys can WhatsApp and direct messages to me as well. And with any questions, off related or art related, you guys can write the question, send a picture associated with the diagram, and we will respond when we have the chance. And also, please note, next video, we have some big updates regarding our official project. We have something ready for you guys. We will show you in the next video.